Most of my larger pieces of equipment are still in deep storage thousands of miles away. Besides, a lot of my old stuff ranged from sloppy to dangerous. I got non-zero budget now, so this is the first of a spread out, probably handful of videos in which I've rebuilt my testing and destruction kit bigger and better. I need a ballast controller, a capacitor bank with voltage doubling for up to 400 volts DC, and a main power switch with remote on-off capability. Depending on schedule, items may appear in use before the video showing their construction is released. Variac I can get shipped over, though that will eventually be supplemented by one that can handle more current. In the old setup, the ballast option was integrated with the cap bank as a charging current limiter on the input side. This time, I want a standalone device with options for ballasted AC or feeding the new cap bank. I will include an option for ballasting the output of the cap bank this time, though. I made that mistake before and killed a fluorescent tube too soon with a very anticlimactic pop. Unlike previous cobbled-together monstrosities, I'm attempting some degree of build quality here with a metal 2-gang junction box and proper non-metallic cable clamps. Heavy-duty pigtails were out of stock, but an extension cord meant for window AC makes a good donor. I leave enough of a stub on the receptacle end in case I want to use it for something else. Yes, I am using 14-gauge wire, but since this is a chassis wiring application in open air with short runs, voltage drop and temporize are less of a concern. This will be a variation on a split-circuit receptacle, so I break the tabs off each side to isolate the top and bottom from each other. I'm using a single-pole light switch for the bypass. Contacts may get beat up depending on how I use it, but it's easy enough to replace. Time to hook it up. Here's the diagram, as a simple circuit looks like wire spaghetti in the physical realm. Line voltage goes to the hot side of the first socket, or ballast socket. The switch is in parallel to bypass whatever ballast is in use. The output side of the ballast socket is connected to the hot side of the load socket. The neutral from here goes back to the neutral of the power cord. Adding the ground wires afterwards was a vain attempt to keep it from looking like such a tangled mess on camera. I'm not used to installing in such a box, so I had to wrestle the breakaway tabs to get receptacle and switch to fit the cover plate. So I don't forget and end up with a very unintentional fireworks show, I put labels on before final assembly so I can confirm what goes where. Switch towards ballast socket means ballast mode, and switch towards load socket means bypass mode. All goes together with a little bit of encouragement. The second cable clamp is there in case of future expansion, such as integrating as an assembly with the cap bank. Before applying power, I check for any shorts and make sure the logic is sound. With no ballast connected in ballast mode, there's zero continuity between hot prong of the cord and the hot side of the load socket. Putting the switch to bypass connects the load. Everything looks good, time for a functional test with 40-watt incandescent bulbs. Lamp on left is load, on right is ballast. Starting in bypass mode, load lamp is full brightness. Switching in the ballast cuts it down while the ballast lamp illuminates, exactly sharing the voltage between them. Now for something silly, a 1600 lumen 16 watt dimmable LED on the load side with the same 40 watt incandescent for ballast. LED reaches essentially full output while incandescent barely glows. Here's something unexpected. When I bypass the ballast again, the LED surges beyond maximum output before dimming back to normal. I may be wrong, but it looks as though the driver in the LED interprets anything over a certain voltage as a command for full power and compensates for small amounts of voltage sag. When line voltage jumps up, it takes a second to back down the driver in response, something to play with in a future video. Using the LED as ballast for the incandescent behaves the same as before when in ballast mode, though the incandescent obviously doesn't do any weird surging when full voltage is applied. Alright, for the last trick, here's a worn-out UVC germicidal lamp hooked up to the ballast with a high-voltage ignition source present. I wonder if we can get anything to happen. Definitely don't try this at home, UV shield goggles required. Can you tell I was nervous? With only 120 volts available from the line, this cooked lamp has no chance to remain lit, but it gives me ideas already. Stay tuned, everyone.